I am Soumojit Roy, Assistant Professor of Huldia Institute of Technology in the Department of CSE AIML. Today our topic is Mastering Bagging Ensemble Learning Technique in Machine Learning. So let's start our learning journey. Let's move on to the next slide. The first point is the introduction to ensemble learning. So we have to first learn about what is ensemble. We have to understand what is ensemble learning. Ensemble learning is nothing but that one kind of hybridization technique. You can say that this is a one kind of hybridization technique. It's actually working on the wisdom of crowd principle. What is wisdom of crowd? Actually, you can't in our real life we can't rely on a single person decision. We take the decision from the multiple person, and then we get into the decision, right? So this is the in our real life world we also apply this technique, and for machine learning domain this is actually called as the ensemble learning, right? So the first point is, what is ensemble learning? That is simple point, combining multiple models to make a stronger and more reliable prediction. What is that? Actually we taking the decision from the multiple algorithm. Okay, right, we're taking the decision from the multiple algorithm, then we get the ultimate decision through voting, right? So this is actually the basic principle of ensemble learning, and it actually have three categories, mainly three categories. The first one is bagging, the second one is boosting, and third one is tagging. But in our today's topic we actually will be focusing on bagging technique. Actually bagging is nothing but the working principle of bagging is nothing but depends on the bootstrap and aggregating step. We will discuss this thing, what is bootstrapping, what is aggregating, in our next slides, right? So let's move on to the next slide. Look, what is bagging? Look, bagging is a simple ensemble learning technique, what is example learning? Again I am saying that we actually apply multiple models to get the final result, right? uh, to get the final result, how we can get the final result? We are taking decision from multiple models. We are going to hear their decision, then we perform the voting, and then we make a decision that okay, this classifies or under these things, right? Not we actually really rely on this single algorithm. Okay, that is the main agenda of bagging. Okay, and which actually contains two main stages. One is bootstrap, another one is aggregate, right? Oh, that's why the name of this algorithm is bagging. Okay, bootstrapping and aggregating, right? That's why in our second part we can see that the technique that builds multiple models by training them on a different subset of data. What is the different subset of data? Actually this is comes under the bootstrapping part. We have a whole data set. Now we making sampling technique. We are using the sampling technique. We get the subset of this data, and and on for each subset of the data we applying different kind of algorithm, and then we get the result and perform the voting. This is and that performing the vote performs the voting and aggregating. This is actually called as aggregating part. So bootstrapping part is nothing but it's divides the not divides, it's makes the sampling techniques. It's actually use the sampling technique and creates the different subset from our data set, and then we perform mm, the algorithm on each data set, and then we perform the aggregating part, which means that voting, and then we get the result. Okay, why we for are using this kind of ensemble learning or tagging? Okay, to reduce the overfitting. So if we apply a single algorithm on our data set, it may there is a concern about that overfitting. Actually I'm saying always saying that we can't rely on 1% view. Okay, so that's why we need multiple view to get the result. Okay, that's the principle of ensemble learning, and all that is the also the principle of bagging, right? And so in that case we get a less chance of getting the error, or getting the error for decision making, right? So it actually prevents the overfitting. That's the concept. It actually prevents the overfitting. that is nothing but reduce the variance of the model uh, prediction by averaging and voting over the multiple bleached learner, right? That's the objective of the bagging, right? Let's move on to the next slide. Bagging workflow. What is the workflow of the bagging? First you have to import the data set and then bootstrap the data set. That I have discussed it, that what is bootstrapping? Bootstrapping is not a, just you have to apply the sampling technique on your data set. You get the multiple subset, and then that every subset you should train on a independent model, right? Independent model, and you can use for classification purpose, you can use logistic regression. For classification purpose you can use decision. For another subset you can use decision tree, that kind of thing. You can use a different kind of algorithm for different subset, right? And then we have to perform the aggregation. Aggregation, what is aggregation? The aggregation, actually we perform the voting. So that there is an example that logistic regression, this is comes under that yes classification, right? And then okay, no, then decision tree says that no, it comes under the no classification, right? That another algorithm says no, it's a yes classification. So in that case, look, two algorithms decided that it comes under the yes classification, and decision tree says that it comes under the no classification. That it clearly stated that we apply now voting technique. And voting technique says that okay, two algorithms gives you that yes classification, and only one algorithm says that it's no, it comes under the no classification. What does that mean? It means that like democracy, that yes classification wins, so that we can say that confirmly says that it comes under yes classification. This is all about the voting, right? So this is first bootstrapping, then aggregating. In bootstrapping we use the sampling technique and creates many more subset in from our data set, then apply the algorithms on each and every data set, train the models, and then get the output. And on the output we get the multiple output from multiple algorithms. Then we perform the voting. Who wins the vote, actually that is the final decision for that classification part. And not only classification, we can also use the regression regression purpose, that we can also use the bagging technique, right? Okay, so that's the working principle, right? The original data split into three subsets. We can also use the 3, 5, 7, any kind of subset. Always use the odd numbers, because odd numbers gives you the leverage in the voting technique, because you also know that that odd numbers gives you the if you use the even number, it may there is a consequence of tie breaking. So to avoid that kind of tie breaking situation, we have to use that odd number of subset. We have to create the odd number of subset, and for each subset we use the independent models, okay, right? So the three models, and attend the each so for first model we can use the decision tree. For second model we can use the SVM. For third model we can use the logistic regression, okay. And then the next part is comes under the aggregating the results. So so the final predictions as either majority voting, okay, right? If again I am saying that SVM says it comes under yes classification, and logistic regression says that it comes under yes classification, but decision tree says that it comes under no classification, then who wins the vote? Yes, actually yes classification wins the vote. Why? Because SVM and logistic regression says that it comes under yes classification, right? So yes classification gets 2 points, no classification gets 1 point. So clearly here wins the yes classification, and we predicted that classification. We classify our output as yes classification. So this is the working principle of in the bagging technique, right? So now this is the diagram. For bagging algorithm. Look, there is a data set. We have to import the data set, then there is bootstrap the model. The first we have to simple techniques that we have to import the data set, then apply the data pre-processing techniques. If we have the missing values, we have to remove the missing values using and imputer, or you can use the mean, median, any kind of imputation technique. After that, we can apply that normalization standardization to make a scale to scaled data. So these are the steps for data pre-processing, and data pre-processing is very much needed for that ensemble learning. Okay, data perform the data pre-processing. It's a very common step for every machine learning technique. After that, we bootstrap the model. What is bootstrap the model? Again, I'm saying bootstrap the model is nothing but creating the subset of the model. Okay, it was like if you have 1 2 3 4 5, these are the data, right? If we make a three subset of these, so 1 2 3 creates a one subset, comes under subset 1, 1 3 5 comes under subset 2, 2 3 4 comes under subset 3. Right, this is how we can create the subset. And then after after applying the sampling technique, we get the bootstrap sample, and that every sample, every subset, we are going to use the models, different models, right? It M1, it may be logistic regression, right? M1 may be logistic regression, M2 may be SVM, M3 may be decision tree. The different algorithm we can use, or maybe same algorithm we can use for M1 equal to decision tree, M2 equal to decision tree, M3 equal to, we can use the same algorithm also. In that case, this is actually called as random forest, right? So after that, this actually comes under the bootstrapping part. After that, we get the result. For M1 actually predict a value, M2 will also predict a value, M3 also predict a value, right? Or gives a output prediction. And then we are going to voting. We are going to voting, and always use that odd numbers of subset. Why we need the odd number of subset? Because for voting, in the voting part, there is no chance of tie breaking. Okay, if you use the even number of subset, and then apply the even number of algorithm in the bootstrap sample part, there may a concern that we get a tie breaking situation. 3 says yeah, okay, it comes under yes part, and 3 says that okay, it comes under the no class. So then it's a tie breaking situation, which is very hectic for us, right? So to avoid this kind of scenario, we actually use the odd number of samples, right? Odd number of samples, and then we have to apply the different or maybe same algorithms on each and every subset. And then we perform the voting. Okay, after the voting, who wins the vote, which class wins the vote, this is the final output for our model, right? And this is the concept of bagging algorithm, and which is we can see in our diagram data. Then we bootstrap the model using sampling technique. Then we apply the different or same algorithm for each and every subset, and then we get the output of the every model, and we perform the aggregation and voting. And then who wins the vote, that is the final output, right? Final outcome of our model, right? So go to the next slide. What is the advantage of bagging? Look, bagging, the main principle of ensemble bagging is actually we get actually better result, because it's actually not prone to overfitting, right? Why that's not prone to, it's not rely on the single model, right? Single model wisdom. Okay, it's actually apply the multiple model wisdom. That's why it's not prone to overfitting, right? So the first point is improve accuracy. So because of it's not prone to overfitting, that's why we get the more accurate, not an accurate, more accurate result. Okay, so the improved accuracy by combining model, bagging helps improve prediction accuracy, which is very obvious. Robustness, less sensitive to noisy data and outliers. That's a very important point. It's not because it's applies much more multiple algorithms. So that's why it's not very much outlier prone things. Okay, parallelizable models can be trained in parallel. Okay, these are very look in boosting. These are serial kind of algorithm, but it's work in the parallel mode. Okay, so the three of or multiple algorithm actually works parallelly. Okay, that's why that's not very time consuming. Okay, so parallelism is one of the advantage of bagging, that models can be trained in parallel, which speed up the computation on large data set. That's the main thing. Okay, right. Because we actually multiple models works parallelly, right? In boosting, that is not a parallel uh, algorithm. Okay, that's the main advantage, one of the main advantage of bagging. And what you can use any multiple any model, right? That's why it's working with any model. Although typically used with decision tree, bagging can be used with other machine learning. Okay, typically it's used with decision tree. That's why random forest is very famous. If you use the decision tree in the for the models, just we create a different subset and just use the decision tree for each and every subset. This scenario is actually called as a random forest algorithm, and which is actually very much famous. That's why bagging is also famous for a random forest algorithm, right? So that's another advantage of bagging is it's actually work with any model. It can work with any model. You can use SVM, you can use logistic regression, you can use any kind of algorithm. You can know that you can apply on that bagging technique or in, right? So that's another advantage. These are the advantage of bagging technique, right? So next what is the disadvantage of bagging, right? The computational cost requires attending multiple, so you need is the multiple model. There is multiple models, there are three models. You can use the five models, you can use multiple models, you can use 10, 11 models, right? So on that case, it's very obvious that it will take some computational cost. It will take some time to solve, to get the result, right? Reduce imperability. Look, interpretability, reduce interpretability. Why it is reduced interpretability? That is very obvious. Look, if you use one algorithm, okay, the interpretability is much more higher. You can you can capture what is happening on that algorithm. Okay, but now you are using multiple algorithm in on parallel mode. That's why that interpretation is maybe harder than a traditional machine learning algorithm, and that is very obvious. But that's not comes under, I don't think that's not comes under the disadvantage. You can consider it as a disadvantage because it also reduces the bias, right? That's why that's the main it can't reduce. That's the one of the main disadvantage of bagging technique. Okay, it's actually reduce the variance, right? So that's why it's not prone to overfitting. But the bit, if base models has a very high bias, bagging can't help on that kind of scenarios, right? So that's the main disadvantage. I says that that is the main disadvantage of bagging. Bagging actually reduces the uh, variance, right? So that's why it's not prone to overfitting, but it can't. But it can if your model is prone to underfitting. If your model is prone to underfitting, that your ensemble and that your bagging technique not will be up to the mark for that. That is the main disadvantage of bagging, right? So go to the next thing. The most I have discussed it earlier, that most popular bagging technique is actually random forest. Random forest is nothing but a special kind of bagging technique. Why this is called as a special kind of bagging technique? Because look, that's the random forest is a special kind of bagging technique. It's actually why that first it bootstrapping the model, creates the subset of the model, then apply a decision tree for each and every subset. And that is uh, the specialty of a random forest. Okay, So the special case of bagging where decision tree are used for base learners. What is a base learner? Base learner is nothing but that models you are using for each and every data set, right? Each and every subset, right? So these are the call for if your base learner is all decision tree, then in that case we call that kind of bagging technique as random forest, because this consists mere multiple trees, and multiple trees makes actually the forest. That is why we get that nomenclature, that random forest, right? The key feature of the random forest is at each node a random subset of feature is selected for splitting, adding additional randomness and reducing the correction between trees, right? What is the advantage? The same advantage, as well as bagging. The more robust, reduce the overfitting, reduce the overfitting to individual decision tree. Actually, we know that the main problem with decision tree is actually prone to overfitting. That's the main problem of decision tree, and that's why random forest is very popular. That it's actually solve this problem. We can also prune the decision tree. There are many more technique to avoid the decision tree, avoid the overfitting from decision tree. That is the one of the most useful technique to get avoid from that overfitting in a decision tree is the use the random forest, which is actually comes under the special kind of bagging technique. And the second point is it can handle both classification and regression tasks. That is any kind of ensemble technique and bagging technique. It can also use for classification as well as regression, right? When to use bagging, the next point is when to use bagging. When the base model is high variance, right? When your model is prone to overfitting, okay, it's overfitting and they get the less accurate result. In that cases we can use the ensemble learning. Always remember that ensemble learning actually used for to reduce the overfitting, right? And when you need the robustness, right, in that case you go for the bagging techniques, right? And when you have the computation technique, okay, if your computer is computationally very expensive, and you can the say that we can takes that computational resource. We have that computational resource, we go for bagging technique. Bagging can be computationally very expensive, which is especially with large data set. If you afford that computational expense, for to get the better result, you go for bagging technique. There is no issue, and it definitely gives you the better result in every time, right? You may say that okay, it's not prone to overfitting. You get the wisdom of crowd, that kind of features, and get the better result. Obviously you get the better result from the multiple models, from you for using the multiple models wisdom, right? So that is the main principle of bagging technique, right? Yes, Gurta. So that is all about bagging. Thank you. Best of luck.